So as I have already told you, I will be discussing theory of machines on this Tuesday 7 to 8 session. So all of you are in your undergraduates only, right? Yes or no?
Yes,
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 sir.
sir.
Yes,
Yes,
sir.
sir.
So is there anyone who has not come across this subject during their undergraduates? Theory of machines? Is there anyone? No, right? So everyone is having little bit idea about this theory of machines. So if we first see the syllabus of theory of machines for GATE, then one second. Actually, it should be changed the setting, I guess, so that every time I need not to go and admit the students. I will set this for next session. Please mute yourself. Everyone, please mute yourself. Yes. So if we see here in the syllabus of your this theory of machines, you need to concentrate on some of the specific topics, right? This displacement, velocity, and acceleration analysis of plane mechanisms. All of you have drawn that velocity and acceleration diagrams that we'll see later. Similarly, dynamic analysis of linkages, then this cams, gears and gear trains, flywheels and governors, and balancing of reciprocating and rotating masses and gyroscope. So actually some of the portion you must have studied under kinematics of machines, some of the portions you must have studied under dynamics of machines. We will see what is kinematics and what is dynamics, right? uh, but before that you can have some references. So if you want to study this subject from NPTEL, this here is one good course, Kinematics of Machines by Professor Ashok K. Malik from IIT Kanpur. Textbook generally used for GATE in this subject is This Theory of Machines by S.S. Ratan, and I have listed some more reference books also, so that if some of the curious students wants to know this subject in detail, then more practical aspects is discussed in this reference books, right? So if we sorry, actually I need to go every time and admit students. So here let us start with introduction. So here, as you know, this subject is this theory of machines, right? And as I have told you, there are two different branches of this subject. One is kinematics and the other is dynamics. In case of kinematics, what you are going to do is you are going to study this displacement, velocity, and acceleration of different machine elements without considering the force, who has generated this motion, right? So in kinematics of machines, you must have studied this displacement, velocity, and acceleration diagram. Then you must have studied that cams, right? So whenever you are studying all this, you are not considering the forces which has generated the motion in this machine elements. While when you go for dynamics, you will study the forces which are acting on different machine elements, right? Different machine elements, as it was mentioned in your syllabus, that dynamic balancing and that dynamic forces, right? So in dynamics of machinery, you must have studied the forces acting on that crank pin or torque generated at crank pin in that piston cylinder arrangement, and that inertia forces and all you must have studied in dynamics of machines. So here there is a difference between kinematics and dynamics. So here mass is not going to be considered, right, when you are studying the kinematics. But in case of dynamics, you have to consider mass also when you are going to see the forces acting on different machine elements. Right, so this is the basic difference between kinematics and dynamics. Now, excuse me again. So now, if we see again the subject, this theory of machines, right? So as you can see here, the most important thing is this machines. So you must have idea about the hierarchy, how the machines are built actually. How can one reach to build a machine? So there are various components and elements and different things in order to manufacture or fabricate machines. So if you want to have a machine, you must have mechanisms, right? If you want to have machines, there are number of mechanisms who will made this machine. Actually, machine is anything which can convert your one type of energy into other type of energy, or it can transform as well as it can transmit motion. So if you give input, there must be some output. It may be in the same form of energy, or it may be in the other form of energy. So anything which converts your given input to either in the same form of energy or in the different form of energy, right? As a fan is also a machine, but in that what happens is electrical energy is converted to mechanical energy, right? Your gear is also a machine, but in that what happens is mechanical input is converting to mechanical output only. So this is how there are various types of machines. So in order to build these machines, these are the building blocks of machines. You must have mechanism, and mechanism can be achieved through kinetic chains, right? So kinetic chains will help you in building this mechanism. When you fix any one of the link of this kinematic chain, then you can have mechanism. We will see definitions of all this in detail, but for your information only I am writing this hierarchy. And for kinetic chain, you must have kinetic pairs or kinematic pairs, right? And to generate kinematic pair, you must have kinematic link or kinetic link, right? So here this is how you can reach to these machines, right? So what we are going to do is we are going to start from this link, right? And we will see one by one what are the different things and how we can reach to this machines. So if we start with link, then there are various types of link, right? So you have rigid link, right? Then flexible link and fluid link. So as you can see on the screen, the rigid link means here see this piston is one of the link, right? This is connecting rod, this is another link, right? Here you are having this camshaft, right? That is also one of the link, right? And this cylinder is fixed, so it is also one of the link. So here you are having this simple mechanism, right? So these are your different links. So if you see and observe here, all the links are rigid link. Now what do you mean by rigid link? It means whenever your this mechanism will be under operation, there will not be any deformation, right? Deformation will not be present. It will be there, but it will be very minute deformation which cannot affect the performance of this particular mechanism. So we can say that deformation is almost absent in case of this rigid link, right? So now what is deformation, that I guess all of you are knowing about it, right? If you are having this link and you mark 2 points on your link, right, let us say A and B. So whenever this mechanism is at rest, this A and B, distance between this A and B is going to be x, then whenever your this mechanism is going to be under working condition, at that position or at that time also, or after your one of the cycle or n number of cycle also, this A and B point must be apart by the same distance x. This is the basic fundamental thing in case of a rigid link, right? So this is how you are having this rigid link. And actually, before even this types of link is any element of your mechanism which is having relative motion with respect to other element, right? Then it is termed as link. And when you term anything as link, these are the different types: rigid, flexible and fluid. And in that we have seen this rigid. So in that rigid you are having almost absence of deformation of the particular component, right? So now if we move to the next one, that is flexible, right? So in flexible link, as I have mentioned over here, in flexible link you may have a little bit amount of uh, deformation, right? But that deformation is not going to affect the performance of the mechanism, right? Here you are having this belt drive, or let us say this rope drive, right? Or here you are having chain, right? So if you consider, then whenever this particular components are under operation, there may be little amount of deformation will be there, but it is not that much that it will affect the performance or the cause of any particular component. So that way you can have this flexible link, right? And the last one is this fluid link. So as you know, when you are going to use any this hydraulic lift or jack, right, hydraulic lift or brakes, right, or jack, whatever you are using with this hydraulic, in that you are having fluid as a link. So as you can see here, the footrest is providing certain amount of force to this, and because of that this fluid is expanding in certain cylinder in order to apply brake or something like that. So this is how you are having this different types of link, right? So once you have idea about different types of links, then you can go for the different relative motion between these links. So as you can see, there are various types of relative motion. First we will see completely constrained motion. Completely constrained motion, right? So here completely constrained motion means whenever you are having a pair between two links and you are going to provide force from any direction, as here this arrow shows force from this direction, you may provide force from this direction, you may provide force from this direction. So irrespective of the input direction, if your output direction is fixed, as you can see, a square road inside this square hole will have only one output. Whatever input you are going to give, or in whichever direction you are going to apply the force, only this will be your output direction or output motion. So this is how, when you are having any this kind of pair, then that can be considered, or this kind of motion can be considered as completely constrained motion. Similarly, here this is first example of completely constrained motion, right? If you go for this second one, here what happens is you have a circular shaft in next is kinematic pair, as someone was asking, kinematic pairs and joints and all. So there are various one second, someone is there. Okay, now in case of kinematic pair, there are various ways of classifying this kinematic pair. One is based on relative motion, right, between this particular elements, right. One is type of closure, and one is nature of contact. So these are three various ways of classifying this kinematic pair. So here relative motion, you are having this various types of kinematic pair. So this can be your link number 1 and this can be your link number 2 for every case, right? This is 1 and 2, so same way you can have this 1 and 2 link in your all the cases, and here you are having various relative motion between them. So if we see one by one, right, then here in the revolute pair you are having only 1 degree of freedom. Means whenever you are having this kind of joint or this kind of relative motion between your two links, you can have only 1 degree of freedom, and the degree of freedom is also shown in this yellow one. You can see that circular motion is provided, so this is the only degree of freedom in this revolute joint or revolute pair. Here in the prismatic pair you are having this translatory motion, as you can see, so this is only 1 degree of freedom you are having, right? In this particular screw pair also you are having, actually your this link element is means having circular motion and translatory motion at the same time, but still degree of freedom is 1 only in case of the screw pair also, right? So this is how you are having this screw pair, or you can say screw joint, right? Here in cylindrical pair you are having 2 degree of freedom, right? So your this cylindrical shaft inside cylindrical hole can translate as well as it can rotate. So this is only we have discussed in incompletely constrained motion, right? So this is 2 degree of freedom in that cylindrical pair. In spherical pair you are having 3 degree of freedom. Which 3 degree of freedom? All the 3 are rotary about all the 3 axes in 3D, right? Because in this spherical pair you are not having any translatory degree of freedom. In our elbow also we are having this kind of joint, so if you try, your this hand can have rotational motion about all the 3 axes, but it cannot translate, right? So this is there in our elbow, this spherical joint. In pen stand also sometimes you may have seen this kind of spherical joint, right? And the last one is this planar pair. In that all the 3 motions, 2 motions are circular, sorry, translatory motion, as we can see here and here, and 1 is circular motion. So this is how you are having this classification of types of kinematic pair, right, based on relative motion. When you go for types of closure, then you are having 2 different pair, right? Force closed pair and self closed pair, right? What do you mean by self closed pair? Here actually you are having cam and follower, right? This is your cam and this is your follower, right? So in this cam and follower, in order to maintain this mechanical contact between cam and follower, you are providing spring force, right? Otherwise this contact cannot last. So whenever you are providing any external force in order to maintain the contact between your links, then you are terming it as the force closed pair. And here in piston cylinder arrangement you are not having any this kind of external forces applied to make contact between any of the 2 links. So these are termed as this self closed pair, right? So this is how your kinematic pair are classified based on types of closure, right? Then based on nature of contact you are again having your classification of kinematic pair, that is lower pair, higher pair, right, and wrapping or wrap type, right?
Sir,
Yes,
came follower may be
yes.
a self-closed pair if it is internal came and follower.
In case of internal cam and follower, actually as per the what we can say definition, if there is no external force in your internal cam, then that can also be termed as self closed pair, right? And if there is any external force, then you have to consider it as force closed. Are you getting me?
Yes, sir.
Okay, so now here again let us come to this classification based on nature of contact. So lower pair, higher pair and wrapping pair. So lower pair means whenever you are having surface or area contact, right, surface or area contact, then it can be termed as lower pair. It means here in this particular piston cylinder, you are here having this area contact, right, or surface contact. So that is your lower pair. And whenever you are having any point or line contact, right, so any point or line contact can be considered as higher pair. Point or line contact can be considered as this higher pair. Where you find this? Here in cam and follower you are having point contact. In your ball bearing you are having almost line contact. So this way you can have this higher pair in those mechanisms, right? And wrap will be there in belt drive and all, right? Means your one of the element is wrapping the other link, right? So in belt drive you can find this wrapping of this particular type of kinematic pair, right? Then after this different kinematic pairs, we can see now joints and kinematic chains, right? So as someone was asking, right, in joints actually you are having mostly three different types of joint we will study most of the times: binary, ternary and quaternary, right? So binary joint means you are having only two links, right, at a particular joint. If only two links are there at a particular joint, then that particular joint is binary joint, right? If you are having three links at a particular joint, right, then that is termed as ternary joint. And if you are having four link at a particular joint, then that particular link is known as joint is known as quaternary joint, right? So one binary joint is actually going to be equal to j only. This we need to remember because we will see degree of freedom, right, in a short while. So whenever we are calculating degree of freedom, number of joint is important. So whenever you are having any ternary joint, then that ternary joint is equivalent to two binary joints. And whenever you are having any quaternary joint, then that will be equal to three binary joint. So this you have to have idea, because while calculating degree of freedom we will consider the number of binary joints only. So if at that time you are having any ternary joint or quaternary joint, you have to convert it into this binary joint, right? So this is how you are having your different types of joints, right? Now if you go for this kinematic chain, then let us see. Now next is this kinematic chain, right? We have seen these joints. So kinematic chain is whenever you are having your number of links joined in such a way that first link is attached to the last link, right? First link is attached to the last link, sorry, then you are you can consider that particular arrangement as kinematic chain. First link must be attached to last link, and all must have constrained motion, as that Sai Teja has just now mentioned, that in your kinematic chain your first link must be attached to the last link and all kinematic pair must have constrained motion. Then only you can consider that particular arrangement as kinematic chain, right? So once you have kinematic chain, right, suppose we are taking this as kinematic chain, you are having your different links. This is very basic, right? So I have this link number 1, 2, 3 and 4, and I have attached with revolute pairs or revolute joints, right? So only one particular motion is there, all the motions are constrained. So here all kinematic pairs are revolute pair, and I have joined in such a way that first link is attached to the last link. So this is my kinematic chain. Now once I am going to fix any of the link, then what I can have is I can have input and output, right? So once I fixed any of the link, then I can achieve mechanism, right, from kinematic chain. So whenever any link of the kinematic chain is fixed, then you can have mechanism in which you can have input, and based on your input you can have definite output, so that you can convert your input to some useful work, right? I guess some people are there. Some more questions are also there. Making WhatsApp or Telegram group, it is helpful. We'll see. I will discuss. Okay, how screw have 1 degree of freedom as it have two motion. That just now I have told you. Now in case of screw, your element is definitely having this both motion, but irrespective of the direction of force, that particular element will move in only horizontal, that one direction only. So that is why this is termed as only 1 degree of freedom, right? And the last is okay, so somebody has, I guess, answered. Okay, so here based on that as here rightly mentioned, that pitch is there, so whatever pitch is there, the same amount of linear transformation will take place. So basically degree of freedom is number of independent parameters required to locate your link, right? So number of independent parameter is not 2 in case of screw also, right? So as he has mentioned, if you are going to provide the pitch, then circular motion and pitch are interrelated. It is not that there will be certain different amount of circular motion and other amount of, or random amount of circular and translatory motion is not there in screw, right? So I guess Abhay has asked. Abhay, can you hear me?
Yes.
Huh. So Abhay, as he has mentioned and I have discussed right now, the degree of freedom is actually the number of independent parameter required, right? So in screw, you can either define the number of revolution or you can define the linear translation. So both are not independent. Only one you need to define. Is it clear, Abhay? Abhay?
Sir.
Huh?
Yes, sir.
Okay. Okay. So let us see now further. 1 second. Yes. Yeah, so you can see my screen, right?
Yes, sir.
Yes, sir.
Okay, okay. So
Yes, sir.
here, yes, here we have this kinematic chain and then mechanism, right? So after having idea about this kinematic chain and mechanism, we will go for degree of freedom. So if we go for degree of freedom, then in 3D actually, if you will have any object, right, in 3D, then what are the possible degrees of freedom? That will be 6, right? Because it can have translatory motion in along all the 3 direction, right? Similarly, rotational motion about all these 3 axes, right? So this is how you are having total 6 degrees of freedom, right? So this is how this degree of freedom, as just now I have discussed, degree of freedom is number of independent parameter required to locate your element in on your space, right? Whether it is 3D or 2D, right? So here most of the times we are going to discuss planar mechanisms, and planar mechanism means we will have single plane, right? So in case of planar mechanisms, right, in planar mechanisms what is going to happen is, if you have any object in this planar mechanism, then what will be the degree of freedom of this object? You will have this translatory motion along x and y, and you will have rotary motion about this particular axis, right? So this is how you are having 3 degree of freedom, with your any link in this 2D, right, 2 dimension or planar mechanism. Here you are having this spatial mechanism, or in 3D you are having this 6 degrees of freedom, right. So if you want to calculate the degree of freedom for any mechanism, then what do you think? If you think you are having total n number of links, right, and all the links are having 3 degrees of freedom. So if I write degree of freedom for a planar mechanism, then degree of freedom must be equal to 3 degrees of freedom of each link, right, because number of link is 3. Now as we have discussed, right, that if you want to move from kinematic chain to that mechanism, one of your link is fixed, so your degree of freedom is 3 into n minus 1, right. And further, if you see, if you are having any link, right, in this 2D xy, right, if you are having this link, it can move in this x and y, and it can rotate, right, all the things is possible, right. But once you provide joint to this link, a binary joint, let us say this is your fixed link and this is your link which we were discussing having 3 degree of freedom. If you joint any of the link to other link with this joint, what will happen is 2 degree of freedoms will be restricted, right. Now it cannot have any translatory motion, it can have only this rotary motion, right. So this is how 2 degrees of freedom are going to be restricted with one binary joint. So I am writing this minus 2j, right. Now in case of higher pair, you are having 2 degrees of freedom, right. As I guess that one student has asked regarding why that this motion is not completely considered and still considered as pair. So in those higher pair, you are having extra degree of freedom. That is why that whatever extra degrees of freedom higher pair is having, that we have to subtract while we are calculating the degrees of freedom, right. So this is how you will have degrees of freedom 3n minus 1 minus 2j minus h, where n is number of link, right, n is number of link, j is number of binary joint. Here you need to be careful, right, this is number of binary joint, right. So this is number of binary joint and this is number of higher pair, right. So this is how you can calculate degree of freedom for a particular mechanism, right. Now before going to calculate the example on this degree of freedom, one more important thing I am going to discuss is whenever you are having any mechanism, right, in that you must have only one degree of freedom, then only you can consider it as mechanism, right. If it is 0, it is a locked chain, right. And let me write that first, degree of freedom, right. If it is 1, then it is mechanism. If it is 0, then it is locked chain, right. If it is minus 1, then it is indeterminate structure, locked chain is structure only, right. And if it is greater than 1, right, then it is incompletely constrained chain, right. So this is how you are having this classification, right. Now one more important thing I was about to tell about this degree of freedom is you can calculate it with this, but sometimes in some very particular cases what happens is you are having suppose this kind of mechanism, right, where you are having this, these are sliding pair is also a binary joint, right. So here you are having a sliding pair. So basically this is your first link, fixed link, this is your link 2, this is your link 3, this is your link 4, right. So what happens in this kind of mechanism is you are having one redundant motion available with your mechanism. Redundant motion, right, present. Redundant motion present in mechanism. Now what do you mean by redundant motion present in mechanism? It means this link 3 can have motion without the input link's motion, right, or output link's motion, because somebody can simply give translatory motion in this direction without affecting this link 2 and link 4 or other elements, right, of this mechanism. So when this kind of motion is present in your mechanism, this is termed as redundant motion, right. So you have to also subtract this redundant motion of mechanism when you are calculating degree of freedom, correct. So this is how you are having this, some of the basic things in your mind when you are going to solve the questions, right, on the degree of freedom, right, in your GATE previous years, right. Now if we go by the different questions asked in GATE papers, then we can see here this is the question asked in GATE 2003, right. Question 29, when a cylinder is located in a V block, the number of degrees of freedom which is arrested or which are arrested is, suppose you are having this V block, right, and you are having a cylinder, right, like this, or better cylinder can be drawn like yes. Right, so here you may have the center line of the cylinder. So now this question I would like you all to try. What I am doing is I am generating a poll for this question, right, and you can give your answer as A, B, C, D, right. This is GATE 2003. I am simply writing 2003, right. Question number whatever, I am writing only Q, right. So your options will be A, B, C, D, right, definitely. So 1 second. So can you see that question? I will end this in 30 second, I guess. 30 second. All of you can answer. 30 seconds. Kindly answer the question. Then we will discuss also.
Sir, can you display the question, sir?
Sorry. Yes,
Question.
yes.
Scale up.
Sorry. Yeah. So please answer the question.
So how to answer, sir? There is no option.
Option will be there in activity. In activity you will find the poll. So should I end the poll or you want some more time?
Yes.
I am ending the poll, right. We will discuss also. One second. I have ended the poll, right. Can you see the result of poll? I guess now you can see the result of poll. Everyone? in activity
Yes,
only,
sir.
right?
Yes, sir.
Yes, sir.
So I guess most of you
Yes,
get
sir.
it correct, right? Answer B, that is 4, right? So here the degree of freedom which are arrested, right? Arrested means restricted. So if we see here, those who have not got it correct, I am trying to make it more clear that when you put this cylinder in V block, what is going to happen is both the translatory motion will be restricted, right? This one and this one, right? And what is going to happen to this rotary motion, that also going to be restricted. Only this rotary motion and the one translatory motion along this particular axis which is coming out of the plane of this particular screen, that will remain present. So out of 6, 4 degrees will be restricted, right? So this is how you are having this particular question. If we move to the next question, so in that can you see the question?
Yes, sir.
Again I am generating poll, 1 second. One second. This question is from 2004. So what I am going to do is, I am not remembering the what we can say question number. I am simply writing 2004. So it is gate 2004, right? So let us go for it. E, B, C, D will be the options, right? So 1 second.
Sir, display the question, sir.
Yes, it will be launched. I guess now it is there on your screen. Again 30 seconds you are having. You can answer the question. I guess all of you got poll, right? I am making you see the question. Again you go for and try to answer it. Read the question carefully. Should I end the question, or I am giving 10 more seconds. 10 more seconds, you can try. Done. I am ending the poll, right? Let us discuss. You can see your results, right?
Yes, sir.
Now let us see what is the correct answer. See here, what you are asked is degree of constraint. So whatever we were discussing till now is degree of freedom, right? So if degree of freedom is 1, means degree of constraint is 5, right? So in revolute pair, as we have seen, degree of freedom is 1, it means degree of constraint will be 5, right? Similarly for cylindrical, as that student has told, it is 2 degree of constraint, sorry, 2 degree of freedom. So it means degree of constraint is 4. And as in spherical, I have told you that 3 degree of freedom means degree of constraint will be 3. So what is that option? I guess all of you got correct, or what? That P is 2, Q is 3 and R is 1, correct, right? So majority of you were correct this time also, right? And those who were not be able to select that, they also must have got idea about this right now, correct? So shall we move to the next question?
Yes, sir.
Okay, so next is, let us see, from gate 2005 we are having this question, that number of degree of freedom of a planar linkage with 8 links and 9 simple revolute joint. I guess this is simple, all of you can try. right? I am again generating one pole. Let me, this is 2005, right? 2005, right? So 2005 will again have option A, B, C and D, and one second, image. Can you see that pole? And you can
Yes.
answer. I guess 30 second is
Yes, sir.
also more than enough. Please calculate and type your answers in poll. And please mute your mic. Somebody, I guess some noise is coming. So everyone please mute your mic. Yes, this is very easy question actually. Number of links and a simple revolute joint is given. So directly you can calculate. When something is not provided, you have to consider it as 0, right? In our that equation of degree of freedom. I guess all of you must have answered, huh? Should I end the poll?
Okay, sir.
Okay, I'm ending the poll, right? So you can see your answer this time also. I guess most of you got correct. You can see your answer, right? And all of you have selected 3 as answer, right? Because in that degree of freedom you are having this 3 and minus 1 minus 2j. Other things are not provided. We are considering it as 0. Number of link is 8 and number of joints are 9. So when you will put that, it will be 21 minus 18. So 3 is the correct answer, right? So let us go to the next question, right? Next question is from 2010. So here from 2010 you are having this question, and I am generating this poll again for this one. 2010. Can you see that question on your
Yes.
poll is also there, right?
Yes, sir.
You can answer this question. Mobility is same as degree of freedom, huh? Mobility of a statically indeterminate structure is, that is what asked. All of you have answered it. I guess I should end the poll because it is very straightforward question, right? So I'm ending the poll and you can see your result. Can you see your result?
Yes, sir.
So
Yes, sir.
it is this one only, right? Whenever you will have that degree of freedom or mobility less than or equal to 1, it is your indeterminate structure, right? Example of this can be given, right, by this actually. If you want, you can have this way, the structure. So if you, these are all link number 1, right, as it is fixed link. Then link 2, 3, 4, 5 and 6. So now number of link will be 6 and number of joint is 1, 2, 3, 4. But what you are going to observe in this mechanism is that every joint you are having 3 links. So remember, this is ternary joint. So one ternary joint is equal to 2 binary joints. So based on this, if you put that degree of freedom 3 into n minus 1 minus 2j, then what will you get is 3 into 6 minus 1 will be 5 minus 2 into number of joints here, 4 ternary joints. So 4 ternary joint, it means how many binary joints? 8 binary joints. So 8 binary joints. So this way you will have 15 minus 16 minus 1, and this is also indeterminate structure. So this is how you can have example of this indeterminate structure. If we go to the next question, this is interesting question, right? So I am generating poll for this. Be little bit careful in answering this one. So I am again generating poll for 2011. So this must be B, C and T, right? So this is how this can you see the poll generated? Hello?
Yes,
No,
sir.
sir.
Yes, sir.
Yes, sir.
2011. Now you can answer for 2011. Do it carefully.
Poll not been generated, sir.
Generated for 2011.
Not for my not visible.
Launch. Yes, sir.
Uh,
I got
now
it, sir.
No, okay, sir.
now okay.
Okay, sir.
Okay.
Yes, sir.
Okay. I guess some student may enter afterwards, so you can calculate the degree of freedom for this one. So should I end poll?
Yes, sir.
Okay.
Yes, sir.
Okay. So I am ending the poll. Here also, I guess almost all of you got correct. Some of them are having some doubt. Let me see. 1 second. It is taking time. End of poll. 1 second. By that time, I guess we can discuss. It is done. Now you can see your answer. Can you see your answer?
Yes, sir.
Yes, sir. Yes, sir.
Okay. So now, as all of you have almost answered correctly, this is 1. Why? Because here when you go for degree of freedom, here in this 3l minus 1, please mute yourself. Somebody is having. The one who has joined lastly, please mute. I guess. Kindly mute yourself. All of you, please check. Hello. Please mute yourself. Okay, let it be. Now, if you see the number of link here, this is first fixed link, then this link 2, 3, and 4, and PQ is a single link, so that is link number 5. And if we go for joint, then this is joint number 1, this is joint 2, this is joint 3, this is joint 4, and this is joint 5. Here it is only resting on it, right? So here there is no joint. Actually, here there is a higher pair. So if we consider all of this thing now here, that is 3 into L minus 1. L is what? 5 minus 1 minus 2. Number of joint is 5. But here we have to consider this higher pair, so we have to consider that one. So 12 minus 10 minus 1 will give you 1. So this is how you are having 1 in this particular case. Now if we go for the next one, again I am giving you a poll. 1 second. This is 2015 session 3, right? I am writing as 3 A, B, C, and D. So 1 second, it is taking time. I am launching. Oh. Okay, 1 second, 1 second. Okay, 1 second, 1 second. Oh, 1 second, I lost my connection. Hello. Hello. Actually, I lost.
Hello?
Yes, sir.
I lost
Yes.
connection. Lost
Yes.
connection.
Yes, sir. Yes, sir.
Okay,
Audible,
okay,
sir.
okay. I need to again share my screen, I guess. 1 second.
Yes, sir.
Sorry, sorry. Can you see my screen?
Yes, sir.
Yes, sir.
Yes, sir.
Okay,
Yes, sir.
okay, 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 okay. So I am again generating poll from 2015 session 3, right? 1 second. Okay. (2015) session 3. Somebody was asking about tomorrow's timing. It is, I guess, 4 to 5, right? Somebody was asking. Can you see the question on your screen?
Yes, sir.
Okay. So this is your question now. Please try to answer it. It is simple. I guess all of you must get it correct. Abhay is telling 7 to 8 is best time. I will pass on this information. Okay, okay. Now poll I should end. Question. Okay, okay. Sorry. Yes. So I guess all of you must have answered it. Let me check how many of you has answered. Yes. So I'm ending it. 1 second. I'm ending the poll. Can you see your results?
Yes, sir.
Yes, sir.
Okay, okay. So this is a straightforward question. In this it is very easy. That answer is 1 only, I guess. How many of you got that answer? Almost all of you, right, who has answered. So here, see, this is fixed link. So wherever fixed link, it will be only link 1 only. Then you will have this as link number 2, this is link number 3, this is link number 4, and this is link number 5, and this is link number 6. This whole is one link only, right? As you can see, this link is joined to 3 link, right? So it is ternary link. Link 5 and link 2 are ternary link. But ternary link is not going to make any difference in our calculation of degree of freedom. What we are interested in is that is there any ternary joint or not, right? As I have mistakenly not mentioned it in previous, and some of you has corrected me out correctly, right? So pointed out it correctly, right? So here 3n minus 1 minus 2j only will work, because here no ternary joint is there. All the joints are binary. This joint number 1, joint 2, because only 2 links are joined, right? So joint number 1, 2, 3, 4, here 5, here 6, and here 7. So 7 joints are there and 6 link are there. So 6 minus 1 minus 2 into 7. So this is how you will have that 15 minus 14 is equal to 1 only, right? So this is the correct answer, right? So let us quickly move to the last question, I guess, of today, right? That is this 16 from 2016. It is very straightforward, I guess. Do you want me to generate poll for this or no? Can you see the question? It is simple.
Sir, no sir.
It is simple,
Yes, sir.
right? What will be the correct answer? Anyone?
Sir, option B sir.
Option B will be correct, right? As we have discussed for planar mechanism,
B.
3n minus 1 minus 2j, correct. So this is how about this degrees of freedom and question asked from that particular area in GATE, right? So